guys, JR here, back with another video on the quotient law.
So, if you divide powers with the same base, so this is the important part of the quotient law, you have to have the same base. So if we have 6 to the 12 divided by 6 to the 9, what do you do for the quotient law? It says if the bases are the same, all you have to do is subtract the exponents. Because if we imagine 6 times 6 times 6, 12 sixes on the top all multiplied together, and then divided by 9 sixes on the bottom all multiplied together, and you start canceling them out, what are you going to be left with? You're going to be left with 3 sixes, and that's the same as just doing 12 minus 9. So you keep the base the same and just have to subtract the exponents. And this is the quotient law. Can I go to the next slide?
No.
So we're going to simplify these, if possible, using the quotient rule. Again, the quotient rule only works if the bases are the same. Then you can subtract the exponents. What about the first one? Are the bases the same? In the power on the top and the power on the bottom? Yes. This is going to equal 4 to the 5. If you ever get stuck, you can think about it in expanded form. Imagine 9 4s all multiplied together. And then on the bottom, 4 4s all multiplied together. If you start canceling them out, you're going to be left with 5 4s all multiplied together. So you'll get 4 to the 5. Part B, are the bases the same? They are. This is going to equal negative 7 to the power 1, which is the same as just negative 7. This will be 2 to the power 2.
2 to the power of negative 1 or negative 2.
This one's a tricky one. What's going to happen in the last one? It's going to be 3 to the power. What does the rule say? If the bases are the same, what do you do with the exponents if the bases are the same? How did you get 2 from 20 and 18? You subtract it. So what do I have to do here? I'm going to have to subtract. What's 6 subtract negative 4? Let's go back to our integers. What does it mean to subtract a negative? That's like adding. So this is going to be 3 to the 6 plus 4, 10. So that one is a little bit trickier. Go back. So I'm going to try these 4. I'll give you guys a head start, then we'll put up the answers. Okay, let's see how you did. Did you see that the bases were the same even though they were x's? And when you subtract, did you get x squared? Did you see that the bases are not the same here? So you can't do anything in this one at this time, other than type it into your calculator and get an answer. This one, when the exponent is not written, can you see that there would be a 1 there? Can you see that these are identical? They will cancel out. And you're just left with b to the 1, although you don't have to write that 1 up there. You can just write b. Can you see if there's 2 b's on the top and 1 on the bottom? They'll cancel out and you'll be left with 1b on the top. In this one, we've got the power x to the 10 and the power x to the 5. Can you see that you'll be left with just x to the 5 when they cancel out? What's going to happen with the 10 divided by 5? 10 divided by 5 is, 2. And there's nothing left on the bottom of our fraction. You could put a 1 down here, but you could just write this as 2x to the 5. Yes?